Hello guys, welcome to the channel. Today we will discuss feature scaling using normalization. First we will see what is feature scaling. Feature scaling means bringing all features means columns to a similar scale so that no feature dominates other. What it means? Suppose I have two columns. I have age column in which data lies between 80 to 60 and I have salary column in which data lies between 20,000 to 1 lakh. Okay. So as we can see, salary's value is much greater than age, right? So when we will build machine learning model, then it will give more importance to this salary column because it is much higher than age column. Okay, which is wrong in our case. Both are important for us. Okay, so in that case, normalization comes into play. Now, what is normalization? Normalization is a type of feature scaling where values are converted into a fixed range, usually 0 to 1. But what it means? Suppose I have a data frame in which I have values 10, 20, 30, 40. Okay. Now I will apply, when we will apply normalization to it, it will convert 10 to 0, 20 to 0.33, 30 to 0.66, and 40 to 1. Okay. So this is how normalization works, and this is how normalization scales the data, right? So this is the mathematical expression for basically normalization, where this is x prime. X prime is basically a new normalized value, okay? And x is your original value, and x mean is the minimum value in the column, and x max is the maximum value in the column, okay? So for these algorithms, we generally use normalization. For k algorithms, k means algorithm, SVM algorithms. We will see all these algorithms one by one. Then we will see supervised learning, unsupervised learning. Okay. So now, so this is the data set. I will apply normalization to these two columns, height and weight. Okay. So see, I will show you how we can do it using Python. So for Python, we will use Jupyter Lab. For using Jupyter Lab, please download Anaconda Navigator. In my system, it is already downloaded. So when you will download it, just search Anaconda prompt, give your file location, press enter, write Jupyter Lab, press enter. It will navigate Jupyter Lab into my browser. I will wait for a few seconds. I will choose this. I will rename this. I will write feature scaling, scaling, normalization. Okay, press enter. Now import some libraries, some required libraries. Import pandas spd, import matplotlib.pyplot as plt, import cbond as sn. Okay, hit press enter. I will take a variable data is equal to pd dot read space will give this is our seventh lecture. I will copy path into the, I will check my first three rows just to ensure my data is loaded or not. Okay, so my data is loaded. Now I have to basically apply normalization for these two columns. So what I will do, first I will separate these two columns. Okay, suppose I will write num calls. I have taken a variable and I will just give the name of these two columns. Okay, whenever we will call it, I will write data. Okay, okay. Okay. Now, first I will plot a graph. Okay, I will plot a graph. I will directly num calls. Okay, this plot. I will give some subtitle before normalization. Okay, tlt dot show. Okay, see, see here. Don't look at the this graph. Okay, see these values 400, 350, 300. What we need to fix is this, not this. Okay, so you don't need to basically see the bar graph, sorry, bars and all. Okay, just see the values. Okay, now how we can apply normalization? For that, I will need to import min max scalar for normal normalization dot pre-processing from pre-processing module of scikit-learn import min scalar, right? Yeah, min max scalar. Okay. Oh, sorry, this is a spelling mistake. Okay. Now I will create an object to call my min max scalar. Okay. Scalar is equal to uh, with tab min max scalar. Okay. I have created an object to call min max scalar. Shift plus enter. Now I will just copy my uh, actual data into a new variable data dot copy. Okay. Now data I will test it. I will sorry I will call num calls for those columns num calls for height and width which I have taken in num calls. I have to perform normalization, so I will call num calls directly is equal to this is the object through which I am calling min max scalar. So just type scalar dot fit transform data num calls, right? So again It will basically it will basically learn the unique values, all the unique values in heights and weight, and transform will basically scale the data. Scale the data means it will convert it like in 0, 1, 0, 0.25, 0.3 like this. Okay. So shift plus enter. Now I will check my data scaled. See, see height and weight column. First see here the height and weight column 1.62. This was the actual data set in which I had the values in height and weight columns like this. And now after normalization, look at the values. It has scaled the values of height and weight. Okay. Now I will plot a graph. Data scaled num pulse dot is plenty dot stop title. Right after normalization, I will give the title after normalization. Okay. PLT dot so see. Now look at the values. Now look at the values 0, 0.25, 0.50, 0. This is the values. And look at here. Here is the values were 1.6, 1.8, 2.0, 50, 100, in 150, in weight column 50, 100, 150, and in height column 1.6, 1.8, 2.0. Now look at the values of height and weight 0.00, 0.25, 0.50, and 0.00. So it has converted, it basically scaled the data. Okay, scaled the data. So this is how normalization works. In next video, we will see feature scaling using standardization. Okay, thank you.